My name is Engineer Stephen Ugwany, and I'm the chairman of the branch. So as a branch, we continue to engage our members, and especially those in Nigeria. One of them is the technical session. Thanks to the technical team for always bringing high quality webinars to our members. We have a lot of other activities that we do as a branch. We're a registered charity in the UK. We have a lot of STEM activities, conferences, we have some technical visits, a whole lot of things that we do to keep our members active here in the UK. And we also support engineering activities in Nigeria as well. So the first part of the event, as I say, is a technical session, and today's session will be dedicated to exploring cable management, the premature collapse and fire-related containment. I believe that this is a key priority for building and construction industry in today's evolving technological landscape. And I'm also sure that this will be of great value to most of us joining here today, especially those from Nigeria, because you know, a lot is happening in this space at the moment. And I'm sure that our presenter today will be able to do justice to that. We're able to explore the innovations and best practices within cable management here in the UK, and of course, the standards. Without wasting time, I will introduce the technical team. We have Engineer Ike Ikechukwu-Monde, MNSC, and Engineer Segun Olaloye. So these are the people behind most of the technical events that we organize as a branch. And I will just quickly hand over to Engineer Segun, who is a chartered engineer here in the UK with over 8 years experience in the electrical and in the design installation of electrical building services. So Engineer Segun, over to you. Thank you very much.
Thank you so much, Mr. Chairman, for your kind introduction. And I want to use this opportunity to welcome everybody to this webinar. Just a few housekeeping, and then we'll go quickly into the webinars. I know our time is far spent. Please, I will advise that everybody please kindly mute so that we can minimize any noise interference. Again, this is a CPD for 45 minutes, and then we take 15 minutes Q&A. The topic is on cable management, premature collapse, and fire-rated containment in building. This is a CPD webinar, so we expect that we'll issue a CPD certificate at the end of it. So kindly leave your name and emails in the chat so that we can collate all the attendees and forward it to our presenter today. So without much ado, I'd just like to introduce our presenter today. Our presenter today is Matt Crunden. Matt has been working in the electrical industry for over 35 years, 25 of which he has been working for Legrand Electric, where he started his career with the company in sales and technical-based roles. After working as Legrand's major project manager for a number of years, it was Matt's passion for learning and teaching others that enabled the forward thinking of the company to create his current role, which is training and BIM manager, a post he has held since 2013. Matt is responsible for developing the BIM capabilities within Legrand UK, while also supporting the Legrand Group with their objectives and drive for digital acceleration. He also has responsibility for creating and delivering in-house and client training programs, including the management of the company's external CPD program. Matt also finds himself engaging more and more with Legrand's CSR strategy and is driving sustainability practices and education within the business. He has also been recognized by the construction industry for his commitment to digital transformation throughout the sector, and is an active member of a number of industry working groups, such as BSI B/555, CENTC/442. He's the chair of CPA's Lexicon project, and is the current treasurer for CIPSI's Society of Digital Engineering. Matt is also a STEM ambassador. STEM stands for science, technology, engineering, and mathematics, and supporting and engaging with young people making life and career choices. Outside of work, interestingly, Matt has been involved in martial arts for over 35 years and has taught the traditional Laogar Kung Fu and other forms of self-defense to many students over the years. Matt is also a fully qualified chef, holding certification in traditional French cookery. So can you all join me in welcoming Matt for his presentation today? Mark, over to you.
Thank you, Engineer Segun, for that wonderful introduction. I'm very grateful.
You're welcome.
And also thank you for inviting me to join you today and to make this CPD presentation to you and your members, which I've really been looking forward to since we spoke. So I'm just going to share my screen. I don't use Zoom very often, so hopefully this will work perfectly.
Perfect,
So I should. Okay, so hopefully you can see the first introductory slide.
Yes, we can see.
Good, perfect, and I hope that everybody can hear me clearly as well. So as you can see, the subject title is Premature Collapse and Fire-Rated Containment. The seminar is actually fully approved by CPD UK, so we will be able to create and deliver CPD certificates for everybody after the event. Obviously, I don't need to tell you who I am anymore. Engineer Segun has very kindly done that for me. So without further ado, let's take a look at the presentation itself. So I'll just introduce you very, very quickly to the company I work for. I work for Legrand Electric Ltd, where a product manufacturing company in the construction sector. So we service the entirety of the built environment, all kinds of buildings and project activity. We're a global operation headquartered in Limoges in central France. And the UK stats are on the screen here. So we turn over 140 million in the UK in terms of cable management and power distribution products. And we've got 700 odd, 650 it says on there. There's about 700 people work for us in the UK, but about 38,000 globally for Legrand. These are the sectors that we operate in. And these are the UK sectors, but these are global sectors as well through data centers, offices, education, healthcare, as you can see the other ones on there as well. So that's the business that I work for. My responsibilities are for training, and I'm also the BIM manager, so digital engineering, building information modeling, and I'm becoming more and more involved in sustainability because we tend to find that the engineers working in the building information modeling world also have a very big interest in the sustainability aspect as well. So those two things kind of dovetail together very, very well. So the presentation subject itself, there are some learning objectives on the screen in front of you. Back in January of 2019, so 4 years ago now, the UK electrical installation standards, as you could see from the first sentence on the slide there, required wiring systems within a building to be adequately supported against their premature collapse in the event of a fire. But since that time, there are two recurring questions that are asked again and again and again. First of all, what is premature collapse? Because although we talk about premature collapse and it's referenced in a number of different standards like BS 8519, for example, there still isn't a definition of premature collapse. And the second question is, how do metallic CMS systems or cable management systems perform in a fire? And the answers to those two questions are quite difficult to put together for lots and lots of different reasons that I'll try and explain as we go through. And, you know, we as a business, Legrand, have been trying to explore and investigate these questions to come up with some answers for the industry. So that's what I'll try to do over the next sort of 40 minutes or so. We have an agenda, of course, which is here. So we're going to begin right at the top with the critical stages of fire safety or fire protection, if you like, which are these three elements here, as you can see. So we talk about prevention, we talk about extinguishing, and we talk about containing a fire with theories like compartmentation within a building to stop fire spreading from one building element to another. But what we're focusing on really today is more the prevention side. So obviously that's around the selection of non-flammable building materials. So it's just really important just to put that up right at the beginning, because fire is something that's affected the industry quite severely over years gone by. And certainly here in the UK, we were seriously affected by the Grenfell Tower tragedy a few years ago, when the building was badly affected by failures in the cladding that was installed, and consequently a lot of people unfortunately lost their lives. Here in the UK, we have a TV channel called BBC Two, and there's a wonderful documentary that really sets out the landscape, which was called The Fires That Foretold Grenfell Tragedy. And the reason that documentary was put together was because we've had previous fire disasters over the years, and I've got some photographs or pictures of them on here. Number one was a Summerland holiday park in the UK. Number two was one in Liverpool, Knowsley Heights. Number three was in Irvine in Scotland, Garnock Court. The fourth one was Harrow Court in Stevenage. And the fifth one was Lacanal House in Camberwell in London. And the reason I put these on here is just to show that all of these issues occurred through the construction, the design phases of these buildings, but lessons weren't learned. Each time something could have been done better, but it didn't actually happen. And it's really the Grenfell Tower tragedy in the UK that's made us focus our minds on what we're actually doing. But there is a question to ask here. And the question is, with all of these things going on, why are we still allowed to use plastic clips and clamps and cable ties and things like that? Plastic systems to hold up heavy metallic systems. When we've got fire situations, of course, these plastic systems just burn away or end up just corroding away in the fire to such an extent that we have this premature collapse problem where the containment systems can drop down to a dangerous level. And again, here in the UK, we've had circumstances where firefighters have been snagged in the cables that have fallen down from a prematurely collapsed containment system. And unfortunately, they've lost their lives in these fire evacuation situations. So it's a terrible problem that we have in our industry. Common sense would tell us that if we're designing products to resist fire, then those products themselves should be non-combustible. But there are no regulations in place that say that we have to use, let's say, metallic fixings and clamps and clips. We can still use those plastic ones that we looked at on the previous slide. Now, what we do know is that when we do have a disaster scenario, we should look at that and work out how we can improve and how we can do things better. And to a small degree it happened, but not as much as we would have liked in the industry. So looking at those fires that I showed on the other slide, after Summerland, there was a tightening of the regulations, but it wasn't a very big tightening of the regulations. The fire disaster at Knowsley Heights resulted in the production of Approved Document B, which is building regulations document for fire safety. After the Harrow Court fire, there were some reviews undertaken and BS 8519 was developed, which we'll look at a little bit later. And after Shirley Towers fire, there were some amendments in the wiring regulations, but nothing really addressed the fundamental questions that we're trying to answer here, which is, what is premature collapse and how do we mitigate against it? And what is the fire resistance of cable management systems? Now, after the Grenfell tragedy, there are now some major reforms coming in, particularly in the UK. We've got a new piece of legislation that's becoming law, which is called the Building Safety Act. That's going to drive multi-levels of competence requirements into the industry. So our industry here in the UK is up for some significant changes because of the Building Safety Act that's coming through right now. So if that sets the scene a little bit, we'll just talk about a few other things that we go through here. And one of them is the Construction Products Regulation. So the Construction Products Regulation is a European directive with a number of 305/2011. And it's basically a set of legislation that tells us how we should place and market products into the construction industry. And when it comes to products, it talks about what we call construction products. And a construction product is a product that's described as something that is permanently installed in a building. So cables are considered to be permanently installed unless they are your little cables that you might have on the end of a mouse, or your cable that plugs your mobile phone in, or your computer. But typically most other cables are classified under the Construction Products Regulation, and they're tested for the reaction to fire. So not resistance to fire, but reaction to fire. What happens to that cable when it burns? And what the Construction Products Regulation does is it classifies the cables. So that might look complicated on the slide, but actually what it's telling us is all cables are classified by the Construction Products Regulation with a code. And the codes are on the central part of the slide, from FCA at the bottom to ACA at the top. And if you look at the text against each of those codes, you can see how they contribute or how they don't contribute to fire propagation. So an FCA cable is a dangerous cable. It's a cheap imported cable, and it'll cause terrible fires. Whereas the ACA cable at the top would probably be something like just a copper pyro type cable, which won't burn and is, I don't like using the word safe when we talk about fire, but it's the safest type of cable that we can use in installations. And what the Construction Products Regulation then does is, once you've categorized your cable code, you can then test your cable for three things: smoke production. So when the cable burns, how much smoke does that cable give off? The second thing is flaming droplets. So again, when that cable burns, does that cable drip with flaming pieces of the coating of the cable? And if you're walking underneath that kind of thing when there's a fire, the less flaming droplets you've got, the better. And the third thing is acidity. So it's the acidity of the smoke. So almost, if you like, how poisonous is that smoke? So you can then begin to classify a cable. For example, you could have a CCA cable, which is central there down in the middle of that chart. And then you could have a category for smoke production, flaming droplets, and acidity. And we're beginning in the UK to see specifiers actually describing with a full specification code. So it could be CCA, S1A, D0, A1, of the types of cables they want to see installed into the buildings that they're designing. So there are two things to think about with cables. One's reaction to fire, one's resistance. And we're talking really here about reaction to fire. What happens to that cable when it burns? There are other standards out there that will talk about resistance. So BS 8519 that I've mentioned a couple of times already does help us to test and rate cables by their survival time in terms of minutes. So, you know, when we typically talk about fire doors with a minute rating, don't we? 30 minutes, 60 minutes, 90 minutes, 120 minutes. That's what BS 8519 is trying to do for the cables that it's talking about as well. But interestingly, there's no fire test in Europe or the UK for cable management systems. So when we think back to those questions at the beginning of the presentation, what's premature collapse and what is the resistance to fire of a metallic cable management system? The second question, there is no fire test standard. There isn't one. And these products also remain outside of the scope of the construction products regulation because they're not considered to be permanently installed products. And they actually are governed by a different regulation called the Low Voltage Directive. So you can begin to see how complex our industry is and the difficulties that we as manufacturers and you as engineers have in terms of how do we navigate our way through all of this complexity to build these buildings that are fire safe. So I mentioned BS 8519 a couple of times. So we'll just have a quick look at this one now. It's around circuit integrity cable. And it was first written in 2010, which was directly after the Harrow Court fire in Stevenage. There was a coroner's report that was written, and one of the results of that coroner's report was the development of BS 8519. It was updated in 2020, so the one that we should be working off now is BS 8519 2020. And it's all around power and control cables for life safety and for firefighting applications and other critical applications as well. But there are two really interesting sections. Well, it's all interesting if you like reading standards, but section 15 and section 16 are the key areas that I would point you to. Section 15 is around cable installation practice, and I've put some text in red there underneath, and it does actually say in section 15, the resistance to fire of the cable containment system should be at least equivalent to the survival time required for the cable. So BS 8519 is really good because it tries to connect these two things together. The resistance to fire of the cable containment system and the survival time for the cable. And it's the only standard that actually tries to do that. So BS 8519 is a really good piece of standardization that we should be using in our industry. And the second really important section is section 16. And if you've read that red text already on the slide, it says failure to observe the design criteria set out in the rest of the standard will result in premature collapse of the cable containment system, which is great. But what it doesn't do is it doesn't define, again, what is premature collapse. So it's still quite difficult for us to navigate this whole landscape that we have to navigate in order to design and build the buildings that we're all involved in. And what you can see here is that BS 8519 talks about using a system approach. And it says there on the first sentence, the support system should have a fire survival time equal to that of the cable it supports. And what we're talking about with the system is when we start combining products together. So maybe that could be your fire stopping, your cable containment system, the hangers, the drop rods, the supports, the fixings, the whole thing becomes a system. So if you don't observe the design criteria, it will result in premature collapse. And obviously we're trying to avoid that premature collapse situation from happening. What we do know is that, you know, the steel is exceptionally strong, as we know, but in a fire situation, when steel reaches about 500 degrees C, it loses about 50% of its tensile strength. So steel is big and heavy, as you know, and if that is collapsing, we need to be very, very careful with how we're designing the supporting structure that holds that system in place, so that if we do have a collapse, the whole system comes to the floor level and it doesn't allow cables to hang at snagging level, which is the area around mid-chest to above the head here, where firefighting teams can get snagged in that containment as it drops down. There is actually a methodology in 8519, which is that methodology A equals W over etc., etc. And what that does is it basically tells you, depending on what type of cables you're using, depending on the span of the supports you're using for your containment and so on, it tells you what size drop rods you should be using. And the calculation does work. We've tested it ourselves, created spreadsheets and put lots of information in there and done some tests and things. So again, it's a good piece of information that we can use for this type of thing. And if we accept that the standard is to ensure that cable is supported for the correct amount of minutes, then it also offers us some benefits as well, because we can adjust the support spans. So if you work with a typical manufacturer's loading table, it might be possible to stretch those supports a little bit, and then you can begin to reduce your overall cost of the project. So although we're talking about, you know, trying to stop fire disasters from happening, we still have to run our businesses, and we still have to think about costs. We still have to think about the best design for the project we're working on. So amongst all this worry about premature collapse and the fire safety and so on, we still can think about, okay, how do I design so that I can reduce costs? Maybe think about these, you know, the support spans, looking at the loading graphs and so on. So there is some benefit that we can take here to reduce the steel content of the installation as well. And that ticks, of course, some of the sustainability targets as well, because if we're using less steel, we can become a bit greener, and then we can drive down some of those costs as well. So we'll talk a little bit about the wiring regulations. These are the British Standard wiring regulations, which are BS 7671. And the wiring regulations were actually first published in 1882, and that's what they looked like at the time. 4 pages with 21 rules. And if you're aware of the wiring regulations, particularly now, you'll know that we're on the 18th edition of the wiring regulations. We're about 600 pages long. We have chapter after chapter after chapter and hundreds of rules and regulations. But actually, what we're trying to achieve now in 2023 compared to 1882, the principles are exactly the same. Don't cause anybody's death, don't kill any animals with bad design, and don't start any fires. And those are the fundamental principles of the wiring regulations. So moving forward to today's wiring regulations, Shirley Towers in Southampton was a fire where 2 firefighters were killed when they went to do a rescue, and the cable containment system had collapsed because of the fire. And the 2 firefighters went into one of the apartments to make a rescue, and became entangled in the cables that were at snagging height. So this level of mid-chest to just above the head. Their breathing apparatus became entangled by the cabling, and unfortunately they both lost their lives. But one of the other tragedies from this particular disaster was that the residents trying to escape the fire couldn't see through the smoke because it was so thick, and they were within 2 or 3 feet of the escape routes, but they couldn't see the illuminated escape routes because the smoke from the cables was so thick. So then we think back again to the Euroclass classifications for the cables, which is why it's so important to specify the cable, the right cable for the job, with that full specification, so we can determine the right, we call it opacity of the smoke. How clear is the smoke? Can we see through it and see light shining through? So that if we had cabled that building to the Euroclass classifications, those residents would have been able to see the escape routes and they would have been able to escape. So hindsight is a wonderful thing, but you know, these disasters have helped us to think about how things should change to a degree. And what happened was, in the 17th edition of the wiring regulations, there was an introduction for a requirement for all the cabling in escape routes to be designed against premature collapse. But in the 18th edition, it then expanded it to the entirety of the building, not just the escape routes. So 17th edition said all escape routes have to be cabled up against premature collapse, and the 18th edition said it's now the whole building, not just the escape routes. So that was a fundamental change, a big change for our industry, because I think it's fair to say that in lots of our buildings that we have these days, we've got ceiling grids with the lights in them. And if you were to lift up those ceiling grids, you'll probably see cables just laid across the grid and so on. And those cables, if they came down, could cause premature collapse. So the 18th edition would say you had to fix those cables into steel containment, or you have to fix them with steel clips and clamps to the fabric of the building. So you're mitigating against that premature collapse as much as you possibly can. One thing of interest again is the wiring regulations still don't define premature collapse. And what's made things even more complicated is in our UK wiring regulations in 2022, there was an amendment made which introduced the term protected escape routes. So we have escape routes already, which are designed, you know, to a very, very high degree of integrity, usually in line with BS 9999. But now we've got the concept of a protected escape route, but the wiring regulations didn't define it very well, and it left the industry very, very confused over what's the difference between the two. How do you determine what an escape route is versus a protected escape route? So there was a further amendment made in May just of this year, so only 4 or 5 months ago, which tried to give some clarity on what is a protected escape route and who should design one. A lot of this used to be put onto the contractor to design the escape route, but it's not the contractor's responsibility. It's the entire design team. The entire design team should be responsible for designing the fire safety rules, if you like, for each of the buildings that we work on now. So we do have some definitions which are down at the bottom of the screen here. Escape route is defined and protected escape route is also defined. I won't read those out now. We'll supply a copy of the presentation afterwards, and you can read that at your leisure and just begin to understand the differences, unless you know them already, which is absolutely fine. So when we talk about protected escape routes, ideally they should almost be sterile environments where you've probably only got a socket in there for cleaning and some emergency lighting. So the two pictures on the slide there, the one on the left is a typical hotel corridor. You could call that an escape route, but coming off the hotel corridor, you might have some protected escape routes, which would be the stairwell that you can see here. But as I said, and it says it in the box at the bottom there, the decision to classify a protected escape route and an escape route is the entire design team. It's not just the responsibility of one person, which it used to be a while ago. It's now the entire design team working together and collaborating. So there's some introductory text that the wiring regulations have published to define an escape route. And it basically says that you should only put fire safety or related fire safety system in there electrically, general needs lighting and socket outlets. And that is it. That's all you should put in there, nothing else. Medical locations have a small exemption, which is on here. I won't read all that out now, but you can have a look at that. But there are some small exemptions for healthcare facilities, but they only deviate very slightly from what we've just looked at. So, as I mentioned before, we've got the Building Safety Act coming into play now in the UK, which is coming into UK law. So it basically means if we don't comply with the Building Safety Act, we will be committing a criminal offence and we will be either fined or we will have a jail term applied to us. So it's really, really key that we understand that and we begin to pick up all of the information that's coming out now in our industry about the Building Safety Act and what it's going to mean for our industry. So there's a few things here I just want to point out. After the Grenfell Tower disaster, there was an independent review made of the building regulations and the fire safety regime that we as manufacturers and you as engineers have to work under. And Dame Judith Hackett, who wrote the report, basically said that our industry in terms of regulations was not fit for purpose, which is why there's all this work going on now. Building Safety Act has come out. We've now got things like the golden thread of information that people are beginning to talk about. So basically, the golden thread is a tool to manage all of the information for a building. So it's unbroken and it's digitally traceable. So effectively, any change that's made in a building design can be traced back to who made the change, why was the change made, and if it's only on cost now and you're putting in a lesser quality product, that will soon, we hope, be something that's outlawed, a thing of the past. If you're substituting a product for a better quality product, that's fine, but there'll still be a digital trace. Who made the change? Why was it done? And all of this will be traceable through the golden thread of information. And the golden thread exists through every stage of the building, from conception all the way through to the in-use and the operation of the building, and even the demolition and the repurposing of that building as well. It's an unbroken chain of information. So there is a definition. This is a very small part of the definition. The definition is actually 3 or 4 pages long, but basically the general definition is that it's the information that allows you to understand a building, but also the information that gives you the steps needed to keep the building and the people safe, both now and in the future. And all of this is referenced within the Building Safety Act. Okay, so it's really important for us. But also, the golden thread of information is stored as structured digital information. So we as an industry are going through a huge digital change at the moment, where we're moving from, the old analog methods and paper-based records and drawings and things, moving into that digital realm where we're using building information modeling and things like that for our designing and our sequencing of our building phases. So the Building Safety Act is going to help to drive the digitization of our industry through concepts like the golden thread. And it also says the government is now going to specify digital standards that we as the industry will need to use. And the first digital standard that's come out through all this is a fire stopping standard, BS 8644. And it's the digital management of the fire safety information. And there's just some information about the document there, but point C at the bottom is important because this document enables relevant, accurate and accessible fire safety information to be made available to the right people at the right time. And why is it really important to say that? Because if you look at the words underlined in red, this is how our industry worked before. Lots of things were conducted in isolation. We worked very independently from each other. Information was rarely defined and structured for the fire safety handover. Generally substandard, analog, largely paper-based, manual processes, difficult. Everything on that slide is what we don't want to be. But until very recently, that is exactly what we were. So these changes are coming through now, which are having a lot of impact on the industry. And there are some real drivers here around those questions that we asked at the beginning. What is premature collapse? And what is the fire rating of the cable management system so we can build our buildings better? We have some good things happening. The advent of building information modeling, so that this will help us with the golden thread concept, because we can create our buildings in a digital environment. We can create them accurately. We can create a digital design from beginning to end using or supporting the Golden Thread initiative. We've got accurate parameter naming, we've got scheduling, we've got takeoffs and all that wonderful stuff. So building information modeling is an enabler, if you like, to the principles of those digital standards that the government is now beginning to drive, using the golden thread of information as a digital information delivery concept, underpinned by the Building Safety Act, which is coming into UK law very, very soon. So growing demand. Okay, well, having said all of that about what's happening in our industry, there's a real ongoing growth now in legislation and regulation, as you can see. So it's really important that we understand that, because all of those pieces of legislation, regulation and standards drive what we do as a business. So we as an industry, that's me, that's you, that's all of us together, have to become more focused in ensuring that the design and the installation of the systems that we put into the buildings can be proven to meet the standards. So really there's a growing need for a demonstration of proof. How can we prove what we're doing and what we're saying? So for a manufacturer of steel products, we can say that steel basically is non-combustible. It doesn't burn. But we also know that clients, when they're looking at their fire strategy, they need documentation for everything. And unfortunately for us as manufacturers, it's whether it burns or not, we still have to provide documentation. But as I said before, there's no European standard to specify a fire test for cable management systems. So how do we do it? This is what we get asked all the time. What is the fire rating of your CMS products? So what we've done is, and this is a challenge for all manufacturers of cable management systems, not just us as Legrand. There are two principal standards that you can see on the slide there, BSEN 61527, which is the cable ladder and cable tray standard, and BSEN 50085, which is the cable trunking standard. But they don't have any requirement at all for product performance in fire. So we've had a look around the UK and Europe, and we found a German DIN standard 4102-12. Now that's a fire test for circuit integrity cables. It's not a fire test for cable management systems. So what we've actually managed to do is to piggyback, if you like, our cable management systems onto the back of the circuit integrity cable test. So when the circuit integrity cables go into the oven, which you can see being built there in the middle picture in the right hand side, our containment systems can be used as the supporting structures inside the oven, which is going to get very, very hot. So we can see how our products perform under a test condition. But remember, it's not a test for cable management systems, it's for circuit integrity cable, but we're joining the party, so to speak, and getting in on the with the testing environment to put our products into that really extreme environment of fire testing. So the way it works is you begin to build up the system on the left hand side there. So there's some of our cable ladders in there. You build the oven around the structure. So on top of those cable management solutions, on top of the ladder, you'll find circuit integrity cable, which is the object of the test. The oven is then built and finished, as you can see on the right hand side, and it's then craned into place. What happens then is all of the cables are connected to circuits, so they're live, and then you can monitor each of those cables for how they perform inside the oven. So effectively, when the light goes out on that particular cable, you know it's failed, so you can begin to see how long did that type of cable last during the test. Was it 30 minutes, 60 minutes, 90 minutes? But what we can do as a manufacturer is that at the end of the test, so this is at the end of the test after 90 minutes, hour and a half, and a temperature of 1,000 degrees, we can then go and inspect our cable management system. And what we found is that there was no collapse of the cable management system in the test instance. So when we talk about what is the fire rating of your cable management system, remember there isn't an actual test. There isn't one. It doesn't exist. But what we can do is we can provide a certificate of compliance or conformance, if you prefer, that tells us under test conditions how long our product lasted for in that extreme oven-based test environment. And there's an example of one there, fire performance and resistance to premature collapse. It didn't collapse, 90 minutes, 1,000 degrees C. So we can provide for the different finishes of product, you know, pre-galvanized, hot dip galvanized, stainless steel, we can provide this documentation. So we talked about evidence-based before. So the evidence-based part of it here is we can now give you a document when you ask for one that hopefully will give peace of mind for your design practices, but also to give to your clients as well, that the product has been tested, and here is a document that tells you that that is the case. So when we talk about evidence, you know, we can evidence by using BIM, designing and installing supporting systems to BS 8519. We can evidence with independent tests, which is just what we were showing, remembering that it is a cable test. It's a German standard DIN 4102, but we can offer a declaration of performance that the products resisted premature collapse for over 90 minutes. So we can give that level of assurance now, instead of just saying, I'm ever so sorry, we don't have anything that we can give you. So hopefully that additional level of proof can offer peace of mind for people who are responsible for designing those fire safety structures and areas within a building. So very quickly, we talk about the future here because we really don't know what it's going to look like. What we do know is that there's an awful lot going on in our industry. There are an awful lot of things influencing our industry now that we didn't have in place a few years ago. We've got a lot of different standards that reference each other, talk about each other. You know, we've got the construction products regulation, those Euro class codes for the cables that we talked about before. We've got the Golden Thread initiative. We've got the amendments to the wiring regulations, protected escape routes, and so on. We've got the Building Safety Act. So what we're trying to do here on the slide is just bring everything together. We can see the different elements that we've just talked about, but it's clear that the standards and regulations all cross-reference each other, much more so than they ever did before. The Building Safety Act is going to take time to bed in, but what we do know is it references digital standards, but it's also addressing and referencing the development of competency standards for our industry. And those competency standards are beginning to come through now. So there are competency framework standards coming through for principal designers, for principal engineers, and so on. And there will be more of these as they come through. And basically those competency standards are there to make sure that those disasters that we've had before don't ever happen again. So in summary, wiring systems must be adequately supported against premature collapse in the event of a fire. Previously, that was just escape routes, but now we've got protected escape routes to think about. We've got formal introduction of competency, so be aware that that's coming down the line. Remember that there's no UK standard for fire testing for cable management, but we do have the German DIN 4102 for circuit integrity cables that we've tested our products to. And there are still no UK standards for defining premature collapse, but there is some work going on to help us to understand what that is. A couple of bits of further learning on the slide here that you can see, a few websites and bits and bobs. And that brings us right to the end. So I'm happy to try and answer any questions. It's a really complex scenario, unfortunately, that we all have to work together under.
Thank you so much, Matt.
It's a pleasure.
Thank you so much for that presentation. It's quite an interesting one. It's quite extensive and it's very applicable to obviously electrical systems within buildings. And you've actually dealt with it extensively. I will hand over to my colleague, Engineer Simon, who will take us through the Q&A session. I believe just because our time is fast spent, we'll probably take very few quick Q&A. So, Engineer Simon, please go ahead and take the Q&A session.
All right, thank you, Engineer Shegun. I actually dropped a note for as many that would want to ask questions to drop their questions in the chat room. And in the absence of no questions there, if you have a question, you could kindly also indicate by raising up your hand, and we'll take about maybe 2 or 3 questions, and we call it a day for this section. Okay, quick one. There's one question from manufacturing point of view. Is there any effort to move into fireproof insulating materials for cable manufacturing? That was by Engineer Alfred. Okay, Mark.
Yeah.
Okay, that's for you. Yeah.
Okay. Well, we as a manufacturer don't manufacture cables themselves. We manufacture almost everything else that goes into a building in terms of digital and electrical infrastructure. But we're heavily involved ourselves in standardization. So we have various people within our organization of Legrand, both here in the UK, but within Europe and globally as well, that actually sit on standards bodies and work within those areas to try and bring that safety aspect to the fore. I think for the question, if it's related more to the cables, we'd probably need to seek some information from a cable manufacturer such as Premature or BICC. But certainly for the cable management systems and all of the other types of products that we do, yeah, we're heavily involved in looking at new product materials, you know, that can be more fire safe. We're very interested in the strictest possible fire testing environments for all of our products.
Okay. Thank you very much for that. Another question reads, what are the process for different type of cables to include fire hazards and demonstration of safety measures? That's from Engineer Afolabi.
Could you just read that one out again for me?
All right. What are the processes for safety for different type of cables to include fire hazards and demonstration of safety measures?
Okay, if I've understood the question correctly, it would be around the design of products. So it would be around making sure that when you are designing products, whether it's a cable or any type of product these days, that you are fully respecting the standards that govern that type of product, any regulations that might exist in your locality, whether that's the UK, whether that's Europe, and just making sure that you're creating the products to the highest possible levels of safety. Because we spoke about the Building Safety Act before, and what we do know is that under the Building Safety Act that's coming through in the UK, there will be a building safety regulator, so a new position, if you like, in the industry that will be able to stop buildings from being built if products are found to be substandard.
All right, thank you very much, Matt. I think I will just take one more question from my side, and maybe that will be all for the evening. Following the fact that there are several standards, the industry standards for cables and safety that engineers need to deploy for able to be able to contain fire containment and all that. Now, would you say if we start looking at smart materials or composite materials or high performing materials for cable installations, would that be a possible solution for the future? And can that really be the solution we need in terms of structural development?
Quite possibly, yes. I think the development, the technological development that we're going through right now as an industry and wider than that, in everyday life, is to such an extent that looking at things like composite materials for new builds and so on can have some real good benefits, because it's exploring things that we've never done before, and that can be a good thing. And also, if we can tie into that the sustainability factor as well, so that we can find materials that are greener, that are more environmentally friendly, but also being as safe as possible. So we're making sure that we're covering all of those aspects. Then I think that is the future. I think for me, if I was taking my career choices again now, my career choices when I was younger were to look at catering, and as Engineer Segun said before, I'm a qualified chef, so I went down that path. I think I would certainly look at engineering now, because of all the advances and the things that we can do together to make all these buildings better than we ever have done before for our future generations, really.
Yeah. All right, thank you very much. I am very impressed and glad with the knowledge you have given to us thus far. I think in the absence of no other questions, again, this will be how far from my end. I'll kindly hand over back to the chairman, who will continue with proceedings for the meeting. Thanks so very much, Matt, and thank you all for your questions.
My pleasure.